So for the first two problems, you're going to be working with an array of data that is student exam, lab, quiz, etc. data from a previous year that has been suitably anonymized and a bit of noise added. So I thought I'd go over the add noise script so you can see what this looks like. You can use it as a starting point for your first two lab problems. So this comma-separated value read just reads in this data file that I already made. You can open this up in Excel or a text file or text editor, anything you want. So this creates an array of data that has 229 entries in it with 9 columns. And I've put the columns here for you. So I've put these here for you. These are the different columns of the data. So the first one is the little mini lab quiz that you do in class, the ZY books, your actual lab scores, homeworks, etc. So I've also made a variable that has line styles so that you can plot in different line styles to make the pretty colors in the graph. Remember, with any of these, if you want to actually get one of the string elements out, you need to use curly brackets. So if it's string columns, we need to use curly brackets instead of parentheses in order to get those values back out again. This is how I added the noise. So rand is a function that we saw in lecture that generates random numbers. So in this case, I want to generate one random number for each element of the data set. Rand is going to generate numbers between 0 and 1. I'm going to multiply them by 2 and subtract off 0.5 so that I end up with -1 to 1 noise. So if we look at noise, it's plus or minus 1. It's plus or minus 1 noise data that I then add into the data file to add a little bit of noise to the data. So this is the actual data that you'll be working with. So again, there are 9 columns, the mini lab quiz, the ZY books, the labs, etc. And each row represents one student. So just a reminder, if you want to get out a single row, you always need to enter which row you want and which column you want in order to get data out. But you can also do an entire column, and you can do an entire row at one time. And then CVS write just writes the data back out again for you. So that's the data you'll use for problems 1 and 2. Go ahead and go work on problem 1 and 2 and then come back here. So for problem 3, you're going to be doing a very, very simplified version of find the minimum. So you've got a parabola plot, looks like this. And what you're going to do is start here and work your way down the parabola plot until you get to the bottom. So I've written this script here for you to fill in so you don't have to do everything from scratch. So you have to write the function from the problem here. And the other piece you need to fill in is the conditionals here. So you have to fill in while, so how you have to fill in looping through the while loop. When have you crossed over the middle, in which case you change delta t, and when have you not crossed over, in which case you change. And that's all you have to write. So just those parts that are labeled as change here, 1, 2, 3, 4, and the original function up here. So just a reminder about whiles and conditions and things like that. So we set up some variables here. So remember, while loop runs over a condition. And in that while loop, we keep changing things. So here we're going to start at x equal to -10, and we're going to go until x is 10. And every time through the loop, we increment x. And this is our counter variable. We always keep a counter variable to see how far we went through. Set a breakpoint here. So in this case, we took 201 steps in order to go through this loop. And this is an example of a while with an else statement in it. So we get a value. And then we either print out if it's positive or if it's negative, and so on. And we stop when x is 0. So this is very similar to the while loop structure that you're going to write for problem 3.